Hi, for video 3 in particle motion, we're going to talk about speeding up and slowing down. This is a very big topic for us in terms of calculus. So this is one we definitely need to pay attention to. Now there are a lot of books out there and a lot of other teachers that tell you different ways to solve this. But I'm going to kind of tell you the basics of it. How do we speed up? Two things have to happen to speed up and slow down. And it deals with concavity a lot of times. So if I'm speeding up, a couple things have to happen. Imagine you're in your car. You step on the gas. You're going forward and you step on the gas. You speed up. Well, another name for the gas pedal is the accelerator pedal. So we say when we're speeding up, two things have to happen. One, your velocity for speeding up, your velocity and your acceleration have to be the same signs. They both can be positive, they can both be negative. Obviously, when you're going forward in your car, you step on the gas, you speed up, you're accelerating. But even when you're going backwards, put the car in reverse, step on the gas, you're still speeding up, but you're going in the opposite direction. Sounds kind of like a vector. To slow down, you step on, to slow down, W-N, can't spell down. To slow down, you step on the brake. Well, the brake is if you're going forward, your brake acts as a decelerator. So you're still going forward, but the brake, the acceleration is now going the opposite direction. So it slows you down. So to slow down, we say V of t and acceleration have to be opposite signs. So notice we're looking at V of t and A of t, both derivatives. So we are going to have to do what I call a double sign test. So let's see what that looks like. So the first thing we're going to need is we are going to need our critical numbers for velocity. And we're going to need to where V of t equals 0. So we need our critical numbers. The first one's for velocity. And we already have that from part A, or from part B, C. When is the particle at rest? We said they were at 1 and 3. T equals 1, t equals 3. We also need the critical numbers for acceleration. Where is acceleration 0? Well, I can get that. Oh, I got that over here when I found my point of inflection there. I take my acceleration, that's that 6t minus 12, set that equal to 0, t is 2. Next what I'm going to do is I'm going to do a double sign chart. Time starts at 0. And remember, no time can be before 0. So on these particle motions, we always start at t equals 0. On the top, I'm going to talk about my velocity. Well, my velocity is at 1 and 3. I'm going to put it like up here. Notice I don't strike it all the way through. You'll see why in a second. Now, I also know my slopes for velocity. I did my sign chart already. It was right here. Remember, it was positive, negative, positive. So it's going to be positive, negative, positive. Notice I drew it pretty big. On the bottom, I'm going to put my acceleration. Well, my one critical number for acceleration was at 2. So I put that there. And then I just look at the signs. Ready? If I pick something like 1, let t equal 1, I'm going to get 6t minus 12. Well, that's negative. If I pick something like t equals 3, I get 18 minus 6. Well, that's positive right there. So now all I have to do is look at the signs. When are we speeding up? Well, I'm looking for where the signs are the same. They are the same between 1 and 2 and 3 to infinity. Where they're the same. They could both be negative or they could both be positive. If they're both negative, this means I am the velocity says on my car is in reverse. My acceleration is pushing on that in reverse. When I hit the gas, I go faster backwards. I am speeding up. So we would say between 1 and 2, because at 2 my acceleration changes, or from 3 to infinity. This is where they're both positive. My velocity is positive. I'm stepping on the gas, pushes me forward faster. So that goes from 3 to infinity And this is because V of t and A of t are the same signs, and that's our reason. Sorry, I had my hand over all that stuff. We are slowing down. This is when they're different. Take a look between 0 and 1. This is saying my velocity is positive, but my acceleration is pushing on it. So it's not making me go backwards, but it is slowing me down a little bit. So we're slowing down when there are different signs. So between 0 and 1, or between 2 and 3. And that is because A of t and V of t are different signs, or opposite signs might be a better way to put it. They're opposite signs. Different would be okay too, but opposite's a better choice of words for this example. All right, so there we have it. There's particle motion. Very easy to do. You only have so we're going to see a lot of this over the next few days. I'll see you soon. Bye-bye.